database. MongoDB is a NoSQL database paradigm that is known for being flexible in the way that it stores data and its performance when scaled largely. According to MongoDB themselves, there are hundreds of large corporations that use their technology in their day-to-day operations. Some of these companies being Ulta Beauty, Bosch, and Sonoma. Unlike relational databases that use Excel like tables and columns, MongoDB changed the way that they store data and opted for JSON-like documents to store binary elements. The benefit of this is that you don't have to follow a schema when designing and implementing your database, but I'll get more into this in a minute. I know what you're thinking. Gage, there are thousands of database paradigms that I can use. SQL, Cassandra, Redis, Firebase, etc. So why would I even use MongoDB? Well, the answer to that is that there really is no answer. Whilst you're watching this video, there is someone out there with their Solr-themed NeoVim terminal open that is writing a brand new database paradigm in Rust that will be marketed as being 10 billion% faster than MongoDB, only for people to run their own tests and figure out that it's actually shit. Anyways, what I'm trying to say is that it really doesn't matter what database paradigm you end up choosing. I've personally found MongoDB to be very fast, I really like their documentation, and it really fits the bill for being general purpose, hence this video. But back to what I was saying. To get started with MongoDB, you can either choose to install their local distribution of software, or you can use their own cloud solution called Atlas. I'm going to use Atlas for this example, but to install the software locally, the steps are pretty similar. You start with Atlas by creating an account. You just need to give them your credit card information, social security number, a PDF of your entire family tree, another credit card number, your full legal name, and create 12 security questions. For legal reasons, the prior sentence was a joke. But create your account and follow the instructions to create your first cloud cluster. There's a huge variety of languages that you can pick from for interfacing with your database. I'm going to use Node for this example, and to get started with that, you just need to use the npm package manager and install Node into your project. Then you require it in the header of your document. After that, you instantiate a Mongo client object, then call the connect function on it, and pass in the URI to your cluster. I want to be completely transparent and honest in this video, as I haven't used MongoDB for any of my real projects outside of writing the code for this video. But from what I've written so far for this video, I find the code to be very concise and pretty standard for code writing for databases. It seems pretty standard to the other database libraries I've used in the past. As previously mentioned, there is no requirement for a predefined schema when modeling your data, and every bit of data that you will store will be housed in JSON-like objects. This differs a lot from relational databases. In relational databases, you actually have to define what an object in the table will look like. For instance, if you want a person object, you would have to say that each person would have a first name, last name, and those are strings, and a height and weight, which are numbers, and etc. This seems fine, but if you also want to store an object for an animal in the same table, you couldn't, because its attribute schema would differ from the person object. But in Mongo, the entries are documents. So if you want to store a person object that has a first name, last name, age, height, weight, etc. in the same table as an animal object that has differing attributes, you can do just that. All this is great, but you need a way to actually fetch your data. And there are multiple ways that you can approach querying when using MongoDB. They support field, range query, and regex searches. Field searches are searching for a sample of an artifact. For instance, if you have a list of books and you want to get the document of a specific book, you can pass the name of the book and Mongo will find it for you. Range querying is pretty much just as it implies. You're retrieving a range of documents from a lower and upper bound limit. One of the best features supported by Mongo is that the user queries can include JavaScript functions. I'm glad they picked the worst language in the world to embed in their queries, but hey, it's there if you need it. Another main reason that Mongo has been used greatly in the enterprise world is its support for replication. I can get super technical with this explanation, but even I would get bored if I did that. So simply put, MongoDB creates something called a replica set. A replica set is a collection of 2 or more copies of the data. When the main cluster fails, Mongo will automatically fail over to the primary replica set. It can even keep going down the replica fail tree if the replicas start to fail as well. MongoDB also supports horizontal scaling with sharding, another prominent reason that Mongo is chosen a lot in the enterprise world. This means that you can create multiple nodes of a MongoDB cluster and distribute your read and write load across them. But the last thing I want to talk about when it comes to MongoDB is what do I think about it. 6.9 out of 10. Anyone remember the 0-day attack that happened to them last year?